All right, everybody, let's wrap up the chi-square test of independence by putting it in the context of null hypothesis significance testing. So quick reminder that here is our scenario. Our general question is, are children's height related to children getting bullied? Remember, we need to make it more technical so we can actually put it to the test. So our general question becomes the research question phrased as, is there a significant relationship between children's height and getting bullied? Now, before we actually get into the full process, I want to show you what the 7 steps for hypothesis testing are. Every statistic has these same 7 steps. The only things that change are how you write your hypotheses and how you calculate the whatever statistic that you need to calculate. But the 7 steps are in the same order and they're essentially doing the same thing in each step. So by the end of this course, you should have these 7 steps memorized and know how hypothesis testing works following these 7 steps. So our first step is after we form our question, of course, when we have a research question, we begin this process. Our first step is identify our variables. Now we did this in the last video, so I won't linger on here, but children's height is our X variable. We see how it's measured there, short, not short. Y variable is getting bullied, yes or no. The second step now is to get into our hypotheses. Now, if you remember back in hypotheses, I showed you 2 versions of hypotheses. They can be non-directional or they can be directional. Now, we're going to get into directional hypotheses, working with those when we get to the stats after chi-square. But for chi-square, the benefit of them is that the hypotheses are always non-directional, right? So you can just take that as a fact. Chi-square hypotheses are non-directional, so you don't have to worry about if they're going to be going one way or both ways or specifying the difference or the relationship, just non-directional. So here's what they look like. Start with the alternative. Remember, the alternative says yes to the question. So is there a significant relationship between children's height and children getting bullied? There is a significant relationship between children's height and children getting bullied, okay? Essentially what this hypothesis is saying, to give you a little more clarity, is that the alternative is the one that says the variables are related to each other. Because if there is a significant relationship between them, it's saying that, well, the variables are related then. It's the affirmative. Now the null says that there is no significant relationship. Remember that you can just copy and paste the alternative hypothesis for your null and just replace the A with the no. There is no significant relationship between children's height and children being bullied. So essentially the null says that the variables are independent. They are not related to each other. So these hypotheses were built off of the research question. So a really good habit to get into is form your research question in the technical way that you've already learned how to do, having the proper order of the phrasing, using the right key technical phrases and words and things like that. And then once you have the research question, it's very easy to then write your hypotheses. So think of it as like write the research question, then write the alternative, and then you can copy and paste and make your null. Okay. Now, let's kind of put this together. So here's our setup. Go to an elementary school, 209 kids you've studied. You have your research question, you have your variables, we have our hypotheses. I've abbreviated them here for the sake of space, but you're expected on your assessments to write them out as I've shown you on the hypothesis slides. Okay, so height is related to bullied, height is independent of bullied. And now our third step is to do our calculation. We did this last time, so you can go back and look at those calculations, the math, how we did that. We got a chi-square of 9.11. Okay, so that shows that O is somewhat different from E. What we found is different from what we expected. Now, to reiterate about the key thing with hypothesis testing is we need to know, is this chi-square score, is it statistically significant? Now, remember what that means. Assuming the null hypothesis is true, was it likely or unlikely for us to find this chi-square score? Assuming height is independent of being bullied, assuming they're not related, was finding this difference between what we observed and what we expected, was that unlikely for us to find, or was it likely for us to find, assuming height is not related to being bullied? So that's what we need to figure out here. How likely were we to find this difference between O and E our chi-square is representing? Okay, so this is everything that I just said. So how do you know something is statistically unlikely? You calculate its probability. You see if it's less than your alpha level, which is usually going to be 0.05. If it is less than, then finding the relationship is unlikely. Okay. Now, finding the exact probability is very, very difficult to do by hand. Now, using the software you're going to use to complete your assessments, the software actually calculates the probability for you. But you are expected to know how you would do this if you didn't have access to a software that can calculate the probability, and if you don't know the more complex math to calculate the probability by hand. There is a workaround that applied statisticians in the behavioral sciences can use to determine if their calculated score has a probability less than 0.05 or not. So this is something called what you would use is something called a critical score. Okay, every statistic has a critical score, and the critical scores are essentially pre-calculated scores for every possible scenario that you could come across. And they're all listed in the critical scores table PDF. Okay, and I'm going to, so again, the one that the Z-score table was on, hope you printed that out or you have a copy of that. Get that open in front of you. If you need to pause the video, do that and grab a hold of that, because I'm going to show you how to work through the chi-square critical score table in just a minute. So the critical score is essentially a workaround. The idea here is that how do I know if my chi-square score has a probability less than 0.05 or not? I can't calculate the exact probability. Well, what if I knew the chi-square score that has a probability of exactly 0.05? Okay, well, if my chi-square score goes past the critical score, it has to have a probability less than 0.05, because the further you get from the center, the smaller the probability is. Right? If it's before the critical score, kind of like towards the center, then it has to have a probability greater than 0.05, right? Because the probability gets greater the closer you get to the center. So if I find the critical score, the chi-square score that has a probability of exactly 0.05, I can just compare my calculated score to my critical score, and that can help me determine if it is significant or not, if it has a probability less than or greater than 0.05, even if I don't know its exact probability. So if the calculated score goes past the critical score, that means the calculated score has a probability less than 0.05. If it's before the critical score, it has a probability greater than 0.05. So here's how you find your critical score. Take that critical scores PDF and locate the chi-squares scores table. You just have to look for the one that has the heading chi-square critical scores. Now, what you're going to see on this table is you're going to see 3 columns to the right. Each of those columns is for a different level of significance. So since our alpha level is always 0.05, you're always going to be looking at the 0.05 column. Now, the rows, if you remember degrees of freedom, we talked about this in the inference section. Degrees of freedom is a number that helps ensure our sample is approximating the population it was drawn from. So every stat calculates degrees of freedom differently depending on the size of your sample. So whatever degrees of freedom you calculate, that's going to tell you the row you'll use to then find the critical score. So you find your DF row, your level of significance column, and you find where they intersect, and that is your critical score. So how do you find the critical score for a test of independence? As you can see in the little equation that I put there for you, DF equals the number of rows minus 1 times the number of columns minus 1. So you got to think of it in like tabular form, like a table. How many rows in the table do you have? How many columns do you have? You take the number of those minus 1 and multiply them together. That gets your degrees of freedom, and then you find your significance level. So for our scenario, we have 2 rows, since we only have 2 categories of X, and we have 2 columns. We only have 2 categories of Y. So we're going to take 2 minus 1, which is 1, times 2 minus 1, which is 1. 1 times 1 is 1, so degrees of freedom is 1. Okay, so go ahead and go to the critical scores table and find the critical score using alpha 0.05 and degrees of freedom of 1. So if you got your critical score, this is an example of what the chi-square distribution looks like. So if you were to plot all of those chi-square critical scores, this is what it would look like if you were to show it on a curve. It's not a normal curve, because remember, non-parametric does not assume normality. The chi-square distribution is actually positively skewed. That's just the way that it is set up. Now, you should have found a chi-square crit of 3.84. that falls about moving towards the right half of the curve. And now we need to compare our calculated score 9.11 to 3.84. So you can see that 9.11 does in fact go past 3.84. Okay, so it goes past 3.84, which means that the probability of the calculated score is less than 0.05, which means that it is statistically significant. So this means that it was, assuming height is independent of bullied, it was unlikely for you to find this difference between the observed and the expected values. It was unlikely for you to find this chi-square value, which means you probably got a sample that was from the tails of the chi-square distribution, and very, very unlikely for you to find. Remember, probabilistically, you should have gotten a sample more towards the center, not from the tails. So because your chi-square score is statistically significant, it was unlikely to find, assuming the null is true. That's evidence against the null. So we're going to reject the null, and we're going to accept our alternative hypothesis, and that becomes your conclusion. So what you first should do is state your research conclusion, which is pretty much a restatement of your hypothesis. So on your assessments, you would just copy and paste your hypothesis that you went with. So we went with the alternatives, you copy and paste your alternative hypothesis for the research conclusion. So there is a significant relationship between children's height and children getting bullied. Now, one of the most important things about conducting science is that we need to take what we find using all these complex statistical methods, and we need to bring it back down to simple language so that way anybody who's following can understand. So if somebody understands the general question, is children's height related to children getting bullied, then we need to give them an answer in the same kind of language. So the second thing you need to do after you write a research conclusion, which is copy paste your hypothesis, is you're going to write a general conclusion. You need to kind of generalize or simplify the technical research conclusion into something simple like the general question. Put it back into the language of the general question. So an example of that we can give here is children's height related to children getting bullied? The general conclusion is children's height is related to children getting bullied. And that would be your general conclusion. That is the final answer to your general question. And that is essentially how you do a chi-square test of independence following the steps of hypothesis testing.